Okay, this thing is on. Good afternoon. Hello.
Hey!
Whee! How was Devox? How many of you have been at Devox Belgium before? Ooh, nice. For how many of you this is the first one? How many of you are watching on YouTube? Like the video? We want to make it the most liked video on all Devox playlists. Right. Anyway, we are starting. Oh, before we start, because the timer is not moving yet, I have a joke to build rapport, so you know that we are just people like you. So here's the joke. What's the scariest plant in the jungle? You need to say what? Let's try again. What's the scariest plant in the jungle? Bamboo. Decent reaction. Probably top 3 that I've got with this joke ever.
So let's wake up and we can start, right?
Yes, we'll start. Welcome to the Fake It Until You Make It session about API integration testing with test containers and WireMock. Let's go for it. Well, imagine you are a Devox and you listen to all those amazing talks and you get inspired, you learn new things, and then you come back home and next week you build something. You build it, and then next time you deploy it, you push it into production, and you broke it. Obviously, what could go wrong? Something always goes wrong. Production always is broken, and then there are bugs, there are things. So you deployed it, and then you have to fix it. But the main question is, did you actually test the things that you've done? And hopefully, of course, you did. Hopefully you did. But this session is going to be dedicated to learning a couple of technologies and a couple of examples how you can test things better, specifically focusing on the API testing. So.
Yeah, that works. So every time we jump on the table, we change the speaker. Okay, so who is familiar with WireMock and Testcontainers? Oh, pretty much everyone. Have you ever used them together? So this is what we will learn about today. So we will show how to do integration testing and how to shift left and how to actually mock your API providers, whether it's a database or whether it's a simple service. And of course, yeah, these tools work really well together. So today we won't fight. Today we will show how the things really work. And there is a lot of cool demos today. So please meet the Olegs. I'm Oleg number 1, Oleg Tinashev. I'm a Jenkins core maintainer. I'm a developer advocate at WireMock. I've also created test containers for C, C++ just a few weeks ago. And yeah, I'm CNCF ambassador and a lot of other hats. But what I actually like about test containers, that is the best framework for doing integration testing and for provisioning containers. And I've been an active user of it since, I believe, 2018 when it was created.
Right.
This is Oleg number 2.
And my name is Oleg Shalaev. I work for the company called Atomic Jar. It's a startup made by the maintainers of test containers. I dropped out of university. I wish I was a doctor. It would be so cool. I'd make everyone call me Dr. Oleg. And you can find me online if you have any questions about test containers or otherwise. I'm there.
Okay, thanks. So back to the original question. I guess everyone does testing. But who does write integration testing on your own?
Very good. Very sophisticated and smart audience. We
Yes.
appreciate you.
Yeah, every time I ask this question, I see more and more hands every day, every talk. And actually, this is what makes me happy. Because when we talk about classic process, when you build, test, then run integration tests, maybe with another department, and then actually deploy to staging, QA, and do tests again, it's slow, it's difficult, and actually it creates a lot of mistakes. As developers, of course, we build, we push, and then it's not our problem. But fortunately, with modern approaches, with shift left, there are just 2 stages left, and build, test, and then ship. And this is shift left. And actually, there is a lot of tools that enable doing that. So today we talk about test containers, WireMock, but yeah, there are plenty of them, and all kinds of CI, CD are actually about making your builds faster, and there are good tools for that. So let's start from the first one.
Right, okay, perfect. So we're going to start with test containers, and I know that most of you use test containers, so I'm going to show a little quick demo for the for people watching online or for people who are not very familiar with test containers, and hopefully I'll try to show a little bit new things that you would love to see. So test containers are open source libraries. They're supporting different languages. They're written in different languages. Java is, of course, supported as well. Otherwise, we wouldn't be here. But you can use the same approach in many, many different languages. What it allows you to do, it gives you the API to programmatically control, manage, use, configure, and consume software in containers. So classically, you would use them in your application lifecycle code or in your tests to create environment for your application to run. It's literally just a library written in Java, so we can use it and put the configuration for creating environment right in your code. We're going to see that in a minute. It comes with a large ecosystem of existing modules, which are, because, well, it's just Java, it's just code. It's very easy to create abstractions that encapsulate lower-level details and hide them from the end users. So we have the library of modules which allow you to run some technologies in just 1 or 2 lines of code. There are databases, there are relational databases, NoSQL databases, there are message brokers, there are other software, there are like WireMock, you can use it with test containers, you can use, I don't know, Selenium or other technologies, you can run cloud emulator technologies. Anything that runs in a Docker container, test containers can run and you can use it, including your own applications, if you will. If you want to build a container with your application, you can do this. Right, so it works for your entire stack. And very recently, we also just announced at the end of summer, and we created a little desktop application that simplifies using test containers-based setups in your local environment. It gives you some developer-oriented tooling, some functionality that you can use for making your test container setups more efficient. So here's how it works. I have my IDE here. This is a little sample project in Java. Right? And I have my POM XML. In my POM XML, I have my test containers libraries enabled, and they come in different shapes. So there is the main test containers libraries, and there are modules for different technologies. So I have Postgres here. So for example, if I go back to my first test, what I can do, I have the lower-level API that test containers supports. One of them, the most important one, if you don't take anything else away from this, just learn about the generic container. We're going to call it Redis. And we can say new generic container, and it takes the Docker image name. Thank you, AI assistant. This is exactly what I wanted to write. So we need to provide a Docker image name to this. And let's say this is Redis, and indeed, this could be like 6 something Alpine. And we can do all the configuration that you would normally be able to do with the Docker container. We can do that programmatically from the code itself. So normally, as a developer, what you do, you would type dot, and then you can just look at everything that it allows you to do. You can configure the environment that you want to have for that Docker container. You can configure which ports it needs to expose to, so you can consume software in the containers. You can override commands. You can copy files to containers. You can follow the logs. You can inspect the container. You can do everything that you can do otherwise, but programmatically from your code. And that gives you incredible flexibility on how you want to run this container. Of course, you have the API for lifecycle methods like start and stop. Test containers has automatic cleanup for many things, and you of course can work with the instance of that container as if that was a normal Java object. So here we're going to run this. I'm going to run this and see what happens. So what we do, we create the container. We want to run Redis in it, and we want to use that from the outside. The test passes. Very good. So it was running. It was running in the middle, and it doesn't run anyway after this. So if I do docker ps, I think the container is not there anymore. Perfect. What else can you do? Can I do besides just running generic containers? I can use the modules which I talked about. So if I do new Postgres container, and I just give you the Postgres module, Postgres 15 Alpine is fine, I don't even have to configure anything here. Why? Because this library coming from the jar file with the Postgres implementation, it knows how to run Postgres. So you don't have to. It's brilliant. It's brilliant. This doesn't need to be here. Right, so we can do start it. We can do self-Postgres container, stop it. I want to show you a cool thing. So I talked to you about the desktop application. It's a little application. It sits here, right here. Right? It allows me to do a couple things. One of them is pretty amazing. It's called services. My containers will start and stop, and by default, they will bind to high-value random ports because I don't want to have any collisions in my CI/CD pipelines. It's the best practice for my integration tests. So, but as a developer, I would like to use my tools in containers as if they are local. So what I can do, I can run this test. I will put the freeze container shutdown, so the containers will not be cleaned up by default and refuse to work. And while my Postgres is starting, what I can do, I can also explore the services menu here. I can open configuration, and I can see that my configuration says anything that runs Postgres, I want to be accessible on 5.4.3.2. And after that, normally in my database viewer here, database, viewer, database, please. Quick. I can use my database viewer as if my application was running locally there. Test connection, perfectly succeeding. That database runs on the Docker container, and we don't even know where. Do we know where? Docker PS. It mapped to random high-value port, but I can use it with my test containers desktop. And you can use all the technologies and work with them, creating environments for the CI/CD pipelines, but locally as well. And it's just glorious. So for anything that requires tests with off-the-shelf technologies, this is brilliant, right? We can use databases, everything else, but stuff still breaks. Why stuff breaks?
Oh, yeah. It's a nice exercise. Yeah, so when the stuff breaks, we actually start exploring the things. And when we do integration testing, there are always two, and both may be a problem, or maybe not. And one thing we often forget is actually API testing, integration testing, contract testing, and everything that we would verify that whatever our client sends to Redis or to our application server is actually what we expect and that it's handled properly. For that, yeah, there is a lot of different APIs available, whether it's gRPC, GraphQL, just REST API, all of them basically receive the request or send the response. And some APIs might be asynchronous too to make it more fun. So I guess almost everyone in this room uses some kinds of APIs to connect distributed systems. And yeah, normally we define 4 levels of integration testing. So whether you test against production staging, which we do not recommend, or whether you mock on the code level with frameworks like PowerMock or Makita, we also do not recommend it because it modifies the code and it actually may lead to various issues and doesn't verify client libraries, of course. So there are 2 ways in the middle. One was presented by Oleg about using test containers, basically putting a simplified instance or a model in a container and connecting to it, reproducing all you need with a real system just in a container. And another one, actually, instead of having a real server, imagine the service may just not exist. You haven't yet developed it, and for that, you can use another tool that would actually just mock the implementation. It would take some definition, for example, OpenAPI specification, or just whatever your logic definition explaining how to react to requests and send the requests. So WireMock is one of the most popular tools in Java. Actually, it has around 5 million downloads these days. And it started as a Java test library, but now it's everywhere, and we will show a few examples. And what you can do with that, yeah, instead of having a service, you can actually have a mock of the service. And this mock of the service is fully controlled, so you can put it to any state. You can trigger any issue. You can use it, for example, for failure injection. You can actually create APIs that you do not have, that you want to prototype and see whether it would work like that while you develop your client. And WireMock is extensible, so everything is covered by extension points, so new protocols, new logic, all of them can be supported. In a nutshell, any mock service, whether WireMock or not, is just a if-then. So you receive a request, and then send a response. So here we just send hello world with status 200 if we get something. But this is a really basic case. One may say that you can write it over the weekend, and of course you can. But actually, WireMock is much more complex than that. There is a lot of advanced features. For example, request matching, you can do form matching, you can do JSON matching, you can apply various XPath parameters. You can also template responses. So for example, introduce variables, introduce randomization there, or maybe introduce counters if you want to emulate cursors, for example, when accessing pagination API. You can also inject faults like delays or errors, or you can just return corrupted data. All of that is possible with WireMock. Another cool feature is recording and playback. So you just watch existing service, let's imagine you don't have open API or you have a service that just exists. So you can record the sequence of steps, the sequence of connects, and then you can create a state machine that reproduces the same steps within WireMock. And there is a lot of additional features. So this is what a modern API mocked service means. It's not just request and response. In the case of WireMock, we actually support multiple protocols. So many of you use it for REST API, I guess, or for HTTPS. We can also support webhooks, gRPC, GraphQL, well, gRPC too, that happens. And yeah, the usage is quite simple. So I guess many of you used WireMock either with Maven or Gradle. You just add a dependency. We distribute it as a single jar, which is mostly shaded with all the disclaimers about it. And you can just add dependency on that and start using it. And it looks like that. You just say in the test that I need to stop a response, and that will return something with some headers, body, and then you put assertions. So this is simple, and this is how you write normally the tests. So whether you have JUnit 5, whether you have JUnit 4, whether you have Spring Boot, there are actually many implementations for that. And there is a bunch of technologies with which WireMock integrates through different API libraries, DSL bindings, or just full-fledged libraries. So for example, if you use Spring Boot, there is WireMock Spring Boot, which was presented on Tuesday at Tools in Action. You want to write Groovy, you want to write in Scala, there are DSL bindings for you. In Kotlin, the same. Moreover, in Kotlin, there are adapters for such co-test for testing frameworks that make it possible. In Quarkus, the extension is available. And beyond Java, there are also implementations, for example, for Golang, for Kubernetes, for Android, and even other languages that normally do not have such services. So this is example for Java. Yeah, again, a lot of technologies available. And we at DevOps, the conference doesn't declare to be Java only. So here's an example for us, in Rust for you. And this is an example with one of the implementations with standalone server. There is, again, the same syntax. We create mock. Then we define hello responses, send a request, and miss the status. So this is how you write it in another code. The problem is that it uses another implementation, which is WireMock for Rust. It has different configuration files. It has different APIs. And this is why actually we are here today together. So if you like, there are also a lot of ready-to-go services mocked. So for example, if you create a client for GitHub, for GitLab, for XKCD due to whatever reason, or for Testcontainers Cloud, you can just take a REST API or Open API definition and import it and get something to start mocking with. So it saves a lot of time, and it's normally click a button. Distributions, yeah, you can run standalone, you can include it in your projects, you can run a standalone in the Docker image or in Helm for your Kubernetes. And there is also SaaS solution, WireMock Cloud, which actually provides a fancy interface for everything. It also adds additional features like chaos engineering. So if you want to try it, come to the booth, and I will be happy to talk about it. But what we talk about today is actually Testcontainers plus WireMock. And I saw a lot of hands in the beginning. So the question, are you sure you use WireMock and Testcontainers together? Have you tried WireMock models for Testcontainers? No, because we've just started. And actually, we created a number of models. We started an official partnership with Atomic Jar. This is a company that employs Testcontainers maintainers and that creates a lot of cool stuff. And together with WireMock, we created a number of official models. For example, for Java, Golang, Python, there is experimental model for C, C++, and you can check it out. So Oleg has already presented an example for Java. I won't be showing it for too long, because here you can see that this is the same container that is provisioned, configured, and then we just run test. So same as presented before, but now with WireMock and Testcontainers. But the real value of that combination actually comes from, not just from combination, but from additional technology stacks. We can support many things beyond Java these days. We can integrate Testcontainers in our frameworks like Spring Boot and provide quite a lot of additional value, especially when you do development. And also, even for Java, there are no things like dependencies. So I guess now it's my turn to actually show that I also can do IDE, not just slides. And I have two examples for you. One example is actually how we do WireMock development on our own. So in WireMock, we ship official Docker image, and to do compatibility testing, we actually use test containers. It's like the same we do in Jenkins project. A lot of our infrastructure is tested with test containers at the moment. But I decided to just show you a real simple example with a few tests and how it looks like in IDE. I will actually show you a little bit more advanced example. In WireMock, there is a feature called webhooks. So every time you receive particular requests with particular parameters, you can actually inform another service. For example, it can be used for observability purposes. So if something fails, if something violates the standard, you can inform. And for that, in WireMock, we can set a configuration like that, where we say that for post requests coming to this callback trigger, we send a response, but we also actually add additional action that sends a response to another endpoint with some additional metadata. And this is served by WireMock webhooks extension, and to test it, we use test containers. So how it looks like? I think it's big. I won't be switching into the presenter mode. So we have test configuration, and in this test configuration, we just have some options so that our CI system, which actually runs it as an integration test, can take another container, another image by hash. But here we take an official image, and then here's our test. In this test, we have some additional features. So for example, we connect loggers so that we can stream data from the containers. And then when we configure the instance, you can see that we actually add a few additional arguments. So we pass the logger. So everything that happens within the container will be actually streamed back for analytics purposes. Then we pass mapping file, which I have just presented, and we enable the extension that actually does the webhooks. And our test, in the test, we actually expose additional ports, because here we have another service which should have been probably packaged inside test containers too, but we are too lazy, so it's separate. And we just start up the server, it waits for the request, and we actually check that everything has arrived. If I run it inside the test, it's actually quite quick. Yeah. Well, it's not that quick. So something, oh, here we go. So it's a local Docker engine. As Oleg said, you can do the same with external system. And here's our test. So everything has passed, so we don't get logs, etc. And this is actually quite good. But it's too good, so let's try to break it. And to break it, for example, we will take not this image, but we try to do this test with the old WireMock image, which is WireMock. Let's try this one. I have no idea what will happen. So it's the last available image of WireMock 2. And again, I just restarted the test. So normally it would be my CI system that takes multiple configuration and passes it through the config. But here I just manually tinkered with the things. And here's our test, which will hopefully fail horribly, but I'm not sure. So while it should fail, because in WireMock 2, the webhooks extension was actually something external. And here you can see that it actually doesn't fail, because WireMock 2 doesn't have health checks embedded in the Docker images. So test containers have no means to actually check that WireMock is doing well, because WireMock, while having messed up configuration, has started up, and we will wait. So this is one takeaway. If you deliver Docker images, please do proper health checks. So then it will fail quickly. But let's let it run.
Wait. While we wait, it sounds like this test container's fault. This is not.
No, it's not test containers.
This is not. So there is a thing called waiting strategies, right? So we expose the Fluent API for configuring a container however you want. So what you can do is, when you start the container, you want to give the control back to the tests. Finally, it failed. So but you don't want to do this too early, because the test will continue doing random things. And if the service inside the container isn't ready, it will fail, right? Like, it's not enough to start the container with the database, something maybe more powerful. Like, say you test against an Oracle database. It will take a couple of seconds to start, and you cannot just check that the container is started and return the control flow. You need to wait until the software is actually available and ready to accept your queries or do whatever the software needs to do. So there are waiting strategies that you can configure in your code, or hopefully the module provider, in this case the WireMock module, would consider the proper waiting strategy, which can be health check. Very often this is log-based, so when the container, the software in container streams something and logs something, and in this default strategy, in this implementation, the wait strategy is to wait for the admin mappings return to 100. So if your WireMock, older WireMock instance doesn't expose admin mappings and return to 100, the test will be waiting for that to be true. So there has to be some compatibility between the test containers module and the Docker image that it runs, which there is another API to make it more bulletproof. But for this demo that was supposed to fail, it wasn't necessary. So it was supposed to fail.
Yeah, it failed. It just failed a little bit later. And actually, you can set up startup timeouts so that it doesn't wait for 1 minute. That test just uses the default one, because we normally do not do integration testing this way. It would fail on the binary compatibility check, even before we reach the integration test in this particular case.
Yes.
And I totally support what Oleg said. It's not a fail of test containers, it's a fail of WireMock 2. And this is why in WireMock 3 we actually have proper health checks and everything goes well. So yes, we have this example. So this is actually how we do it on the integration testing. If you want to explore it, yeah, basically every GitHub action does run GitHub steps. And yeah, here you can just see a lot of things. And yeah, too many branches today. And this is what we actually have. So 2 configurations that we tested, and for each we actually run integration tests here that just Maven execution, which includes test containers, etc., on standard GitHub actions. So works quite good. To assure you that it's not just for Java, who does code in Golang? Okay.
How many of you do Haskell? 3 people? Ruby?
Okay, so I'm not taking Ruby challenge today.
PHP?
That's for sure.
Okay.
No, I'm not taking Ruby challenge. I had enough in Jenkins, sorry. But yeah, let's go to our demo. Actually, you can write code in Golang too. And for that, again, I have something better. Oh, it's not going to work this way. But yeah, if you want to write in Golang, again, there are WireMock models that, again, hide all the complexity, all the stuff. Well, it's still quite long because it's Golang. But here you can see that we start up the container, we pass the mappings, we send the requests, we process the responses. So same as everywhere else. It's just a little bit faster, because nobody would say that Golang is slower than Java, right? So here, if we zoom in, 3 seconds, and Golang test done. So with the same frameworks, etc., and again, it's fully powered by test containers. Otherwise, it would be tens of thousands of code lines instead of just 200s for this model or so. So this is what I wanted to show you. It's just common examples of how we use WireMock with test containers. And again, if you're interested, there is a lot more use cases we would like to show, but we have limited time, so come to our booth. Either Ruby or C++, we have something to present to you, just in a more comfy environment.
Right.
Okay? So
perfect.
Now the stage is yours.
Right. So we saw just the demo, and like it's very, very like sort of understandable how you test these things, right? You create your environment, and your service depends on third-party API. It could be some external service like GitHub or like whatever calendar, Google Calendar or something else. Or it could be a service that is maintained by your peers, by your colleagues, maybe by you 6 months later in history, right? You just don't know it yet. So, and mocking it creates a stub, creates a sort of a double, a model of how it will behave. So the question becomes, how can you make sure that that model is actually correct? Because if I am building a software, I can also, and I'm also building the tests for that, and I'm also building the stubs and examples, what the request response pairs look like. How can I make sure that I'm not building in the same assumptions that also will clearly pass the test because I wrote both the code and the tests, but also will not accustom for the actual real implementation that will be running later? So the answer to that is that you have to make sure that your stubs are actually confidently correct with behavior according to what the external system is. Yep. And in the proper answer for that is, of course, that you need to do contract tests. And contract tests are a whole separate subject that we can spend another session on. But in a nutshell, what it gives you the process, how you can test both the consumer and the producer of the API, that they speak the same language. So if there is a producer API and a consumer API, you want to do a verification, you want to describe what the interaction looks like in some form, preferably in code, and then you want to run on one side tests to check that the producer actually produces those responses when you trigger particular actions. And on the other side, you want to use that contract to create the stub automatically. So when the consumer actually tries to use the stub in the test, in the integration test, they will not be doing like just random responses that they just want to receive, but they actually get some responses that just went through verification. So in a nutshell, there are different approaches how to do contract tests. There are different technologies that you can do contract tests with, but you should be doing that. And it's more about the process of communicating between two different teams than anything else. So you should do contract tests, but if you don't do contract tests, because it involves communication, it involves talking to other people, which is big no-no for many, many people in teams. So at least you can use something to verify, to like sort of, to have those stubs more or less believable. And for that you can use
our tool called WireMock. Because again, WireMock has a lot of advanced features like recording, proxy mode, when you can connect, basically being man in the middle for HTTP services. You can also try being man in the middle for HTTPS services with some considerations, but we try to support you with that. And you can also do a lot of various integration across things like fault injection. But the key thing for WireMock is that when it operates as a proxy, it records all the requests. You can use it for additional asserts. You can use it for dynamic forming of templates because WireMock is fully accessible through REST APIs. And it can also be used for protocol verification because you query WireMock, you query its specification, and every mismatch, it can be reported and can be propagated back to your unit test that actually does it. So you get additional coverage, you get additional safe nets for your APIs and communication.
Right. Yes. So this week we talked about this mocking third-party services. Somebody asked me what would be my approach to mock the Google Calendar API, because it's quite involved, right? And I don't even know what exactly endpoints are there, whether they are properly documented or not. But this is what I would do. I would put WireMock in front of it. I would run my actual software or my actual queries manually through that. I will record the request response pairs, and then will analyze that and pick the particular parts that I need to create this stub for my testing purposes. And then I would hope that Google Calendar doesn't change the API without telling me.
Yeah, you also forgot one thing. You would go to library wiremock.org and take existing stubs so that you don't have to create everything on your own for Calendar API, which is huge.
Very, very good. And that brings us to how we can use those technologies all together in a real-world sample application that is small, but yes, yet illustrates the purpose and hopefully serves as a decent example and a starting point. So the mega demo commences. Let's go to our IDE once again. This is it. This is my Spring application. It's a very small Spring Boot application. How many of you use Spring Boot? Very good. How many of you do libraries and don't care about? Quite a bit. Very good. How many of you use something else? Quarkus? Very good. Micronaut? Very good. Halidon? Drop wizard. I'm just joking. It's a good library, but less popular nowadays. So we have a Spring Boot application, and it's a to-do application. Very simple, because everyone wants and loves task lists. Our model for that application is just a to-do item. It has the ID, the title, and some other parameters, which are not, strictly speaking, important. What our application does, it's a forum web application CRUD to create, maintain, delete, and use to-do items. What it also does, it uses the Hacker News, the orange website, for the news. And if you push a button, if you query this application correctly, what it will do, it will go to Hacker News that we configured here, like to the actual Hacker News database, and it will query the stories that are there currently, and then we'll put them as the to-do items. So if you cannot figure out what you actually want to have on your to-do list, you can just push a button, and then you will have the reading list, if you will. A sample application, it stores data in a database, and it also uses this third-party API. Perfect example to show WireMock and Testcontainers integration in a real project. So we need our test. Here's our application test. Our application test is a normal application test. It's a Spring Boot test. It will spin up the whole Spring Boot application on a random port. And we're gonna use rest assured to query our application to actually send requests to that application. So we know from the actual code that there are a couple of endpoints, for example, get all or /hacker news, that we can use, sorry, the wrong one, that we can use to actually produce results from the application. So what we're gonna do, we're gonna use rest assured to run the query to post to the to-dos Hacker News and expect 200. That should trigger the application to start going to Hacker News, and then we're gonna query the endpoint to list all the to-dos for at most 10 seconds and retry it until it asynchronously produces those results in a database to get the to-dos back, and we know that we want to have 6 of them. This is the business logic because there were 2 built in and 4 coming from Hacker News. Together should be 6. So we can run this test. We can run this test, and it will use the it will spin up the Spring Boot application, and it will try to work with it. So of course it will fail because there is no database. And it might not fail because it can by default go through the configuration. Look, the configuration here was that if anything else fails, the default endpoint for Hacker News is actual Hacker News. So on this end, it will not fail. It will actually just go to production and use production data for our tests, which is not something that we want. But it will not crash. So we need to do what we want to do. We need to create the database for the application environment, and we need to create a mock of Hacker News service in the test container with the WireMock module to pretend be our Hacker News, so we can have predictable, stable data that we can actually work with some assumptions.
Yeah. It was mentioning that especially in Hacker News case, it has to be done because this Hacker News API is V0 with all the disclaimers so that it's not stable. And even when we were developing this application, it went down 2 times. So this is why you have to mock it.
I don't know. I haven't experienced it being down ever.
Lucky you.
It's the most robust orange website on internet. So how do we integrate test containers with Spring Boot? How many of you on the new versions of Spring Boot, 3.1 and 3.0? Decent chunk. Decent chunk. So before it was harder, but in 3.0, Spring Boot added integration with test containers to much bigger level. So now what we can do, we can take test containers objects and we can return them into beans. So I can have a method, I can have a configuration that will tell my Spring Boot that it wants to run with this environment. And in my test, you can see, in my test I'm saying that use this container configuration to create environment for me. In my test, I can say, I want to get the Postgres container, and I want to return it as a bean. That means the Spring Boot will look at that and say, oh, it's a bean, and it's a container. What I can do, I can manage the life cycle of this container for you. We don't call start, we don't call stop anywhere here. Yeah. And it still is gonna run. What else I can do? I can slap a service connection annotation on it, and it will instruct Spring Boot to use this database as the database for the run. It will overwrite any static configuration that we have in application properties or anywhere. So when the container has started, Spring Boot will configure itself to use that database, and we can use it. So this will create our database here. Oops. This will create our database. Can I run my test? Yes, I can run my test. It will actually go to the Hacker News, but I can run my test and it will, I think it should.
Yeah, let's keep our fingers crossed.
Yes, it should work. We will not freeze the containers with Testcontainers Desktop. I'm running my containers using Testcontainers Cloud, which is the backend for running containers during Testcontainers tests. You can try Testcontainers Desktop and enable it with a click. You can see that there is a local data center somewhere nearby, 15 milliseconds away from me. The application runs locally, but my containers are running in that remote on-demand provision Docker environment, which is very, very cool because I don't need to spare my CPU and memory on that. So the application test passed because it actually went and queried that actual Hacker News website. So what I can do now, I don't want to depend on Hacker News. I want to create my WireMock container here. So what do? I expose it as a bean. And here I will need some help because this is a new thing for me. So I do the WireMock container. Of course, I added the library into my POM XML, so there's a dependency so that those classes, the WireMock containers classes, are actually coming to me. So I will get the WireMock container. I will return it as a bean. What do I need to provide? WireMock.
WireMock, and let's take the latest version. So it's 3.1.0-1.
Okay, -1.
Yes.
So this is my WireMock, and I need to configure it. So this is just, it will start the WireMock container with the WireMock server inside the container, right? What it will give me, an empty server that doesn't know anything about the stubs. So what can I do? I can stub it. How do I stub Hacker News? Who knows? Everyone knows. You go to the library.
Yeah. And take the file. The problem is that this file won't quite work because it needs some additional updates. Let me show it to you, if you don't mind. Just
Yeah, sure.
Yeah, so on a WireMock library, you can find Hacker News. Actually, I'm guilty of creating OpenAPI documentation for Hacker News when creating this demo because there was no OpenAPI. Here, yeah, if you go here, you can see that there are some run in WireMock Cloud. If you use our SaaS for mocking, again, just one click and you got it running. And for library, you actually get this not so big file, which was generated automatically based on the OpenAPI specification and some magic applied, because even OpenAPI 3 is a bit complicated. And this is the file which we are going to feed to our application. The nuance is that we added some additional test data to demonstrate the use case. We actually want to show it to you. So maybe after this demo, you will actually get it published.
Oh, right.
Yes.
So we have that WireMock container. We have those stubs here in the local file. We downloaded them ahead of time. So now what I can do, I can take my WireMock container and I can configure it with mapping file like this. We're going to map it from the resource. We're going to say that its ID will be Hacker News. We're going to say that that file needs to be there. And then we're going to return that WireMock container. If we run this, will this work? Who thinks it will work? Who thinks it's enough? A few hands. Who thinks, well, it will not fail because it worked with the actual Hacker News before. So who thinks it will fail? It will not. I just told you it will not fail. Right. One thing is missing. One thing is missing, and it is missing the part where we tell our Spring Boot application to use this WireMock stub as the actual replacement for our external service. How do we do that? We configure it. Remember, in the other controller, in the Hacker News client, we used this property. We specified it. So now we need to override this property for our test run to say that that is pointing to our WireMock, right? So how do we do this? We inject here dynamic property registry, and what we can do, we can feed that registry properties that we want. So we can do registry, add, and we do this, what was it? Come again. Hacker News client. We take this property and we put it back into our property thing, and we say that this is the WireMock container. Get, what do we get?
Just base URL, I guess.
Get base URL. Yes, I think base URL. Very good. So now Spring will manage the lifecycle of WireMock. Spring will also use this WireMock to overwrite its own configuration. So now when we're going to run this test, it hopefully will use our WireMock stub. Can we run this test? Yes, of course. We can run this test. Let's go back and run this test. You will actually, this is, didn't think this through fully. You will not see any difference because the test will actually go and pass again. But if I may, let me freeze the containers for a second. At least I will show you that, look, it is pulling WireMock. It pulled WireMock super, super fast. Ooh, this is cool. I didn't plan this, for sure. But it pulled it so fast because we are not on the conference Wi-Fi. Containers are running in the cloud, so it's pulling image cloud to cloud. That's why it's fast. Here on the local Wi-Fi, it will pull that for a couple of minutes. Right. But it ran the context load, and you can see there are like predefined data there with action items like WireMock and Atomic Jar partnership on test containers and so on. Not the real stories from Hacker News. So they come from the thing. And if we look at the Docker PS, you will see that there is a WireMock container running and the Postgres running and the resource Reaper container running that will enable actually us to clean up everything on demand. So let me unfreeze the containers so they will go away. And our test passes, everything is good, everything is clear. One super advantage of using WireMock inside the test containers module is that you get the common lifecycle with all other dependencies. The same way we handle the lifecycle for Postgres, we handle the lifecycle for our stub. And that gives us an amazing experience for the local development mode, right? This configuration for the containers, there's nothing specific here for the tests, right? We can also use the same code and the same API to create environment for us when we are running our local application locally. So we do this. What do? We have the entry point into our application inside the test class path. Why do we do this? Because we want to have access to our test containers libraries, to our WireMock stubs, and we use the actual real application, and we just augment that with the container configuration class that will create those dependencies. So I can run this thing on my local laptop right now, and it will create that environment for me in my Docker environment, and it will allow me to run the application locally. So if I go...
Now it's our moment of shame, because we are two developers, we don't create UIs. So this is what you get.
This is the to-do application. Look, it runs on the localhost 8080, and it also says that my backend is at localhost 8080. This is a to-do MVC project. It's a stock project with stock CSS and everything. There are two items. Look, I can do the other things. Hello. Hello. Does it actually work? Did we check that it works? Hello.
Things happen.
Okay, I can make complete things and incomplete things. And I can complete things and clear completed things. It's very good. And also there is a button, What's Up on Hacker News. We can click it. And now, instead of going to the actual Hacker News, what we get the data from our WireMock module. And if we click on that, it will go to the sample data from our WireMock thing. And if you want, you can even go to inspect the WireMock mappings. If you want, we use the services to run.
You mapped it like before in the previous
demo. I mapped it before, so I have a service that says WireMock locally runs on 7971, and I can inspect the state of that thing as if it was running locally. So I can run my containers locally with my Spring Boot application, and it's just very, very easy to do that properly. So that said, it succeeded, except adding new to-do lists. That is a bug somewhere, but that was the most minor part of the demo, so I think we are happy about that.
Yeah, one thing that was mentioning, that it can be expanded even more for code development, because you can actually use WireMock APIs to upload stubs dynamically. So if you use a specification of your API, you can develop a server mock and your application at the same time without reloading, just by using REST API of a WireMock container, and get a really great developer experience for your prototypes. So we are running out of time. If you are interested, there is a booth of Atomic Jar. Come there. We have a lot of stickers I still have, I think. And we will be there to answer any questions, whether it's Ruby, C++, and I guess everything else. And one thing, to keep in mind that it's Hacktoberfest, so it's a good time to contribute. Both projects are open source, both projects are waiting for more contributors, and it's a good time to participate and to get some special swag from our teams. So that's it. All the links are here. We have WireMock.org/testcontainers with all the references, with all the solution pages. We also have 2 Slack channels. We also have 2 company websites, and we also have this demo we have just demonstrated.
We're out of time. Thank you very much for watching. Happy testing.